Yes, this is episode 5. I'm Captain Anderson. Episode 5, let's double check the numbers. There was a couple of numbers there that I wasn't certain about. For instance, the Earth's temperature 50 million years ago. Scientists say it was 77. But they don't know that for certain, I don't think. So I thought I'd check on 77. And I also thought I'd check on the fact that the scientists use only the numbers taken from Mauna Loa, which is 13,700 feet. But all of the carbon that's in the atmosphere will one day will warm the Earth, but we're ignoring it for some reason. How much carbon is that? What are we going to do when all of this carbon starts absorbing the heat? So let's check the temperature. What if the scientists were wrong about the Earth's temperature? All right, this is what I did. I multiplied these all out. So this is a confusing graph. I didn't do a very good job of it, but this is the numerator of the carbon ratio. That's the amount of carbon humans have put back in the atmosphere. This is the denominator. This is the amount of carbon that was in the atmosphere before the Earth began to cool. So what I found out was if the numerator stays the same and the denominator over here gets bigger, that means that over here the carbon ratio is going to get smaller. So if I'm multiplying a smaller carbon ratio times a larger temperature differential, what happened? I got the same number. So in other words, I should have known this. The only thing that matters, period, full stop, is the amount of carbon humans have put back into the atmosphere. That's the only thing that matters. The scientific community, bless their academic little hearts, they have managed to confuse the problem to the point where nobody knows what's happening. Well, this is what's happening. It's that simple. Now, how much carbon is in the atmosphere? Well, that's another thing that bothered me. As I say, they're only measuring it at Mauna Loa. What about the rest of the carbon? How much is there? Well, you can't really count it, Okay, so in 1956, our planet over here, 6 gigatons of carbon were being emitted when the global world product was $11 trillion. So the global economy is 11 trillion, and it's emitting 6 gigatons. That was in 1956, which ironically was the first year that Mauna Loa operated. And at that time, they figured out that the rate of increase of CO2 at 13,000 feet was 0.7 ppm per year. But when you go down here, when I did this little study in 2019, the global economy had increased to 95 trillion, because we're so clever, we keep growing and expanding, and we were emitting 36 gigatons. That's a factor of 6. We increased the amount of carbon into the atmosphere according to the International Energy Association and the petroleum industry. We know how much carbon we're burning. So this increased 6%, guys. This increased sixfold, but the rate of increase at Mauna Loa was only threefold. So as an economist, I'm going to make an assumption. I'm going to assume that there is at least twice as much carbon in the atmosphere right now as the scientists are worried about at Mauna Loa. So if that's true, well, then there's twice as much carbon is in the atmosphere. Then that means it's going to have an impact on the ultimate temperature of the Earth. I don't care what anybody says. These are the laws of physics. You combust the fossil fuels, you put the carbon back in the carbon cycle. That's it. So I'm going to do here the same calculation I did before. If you weren't paying attention, I'll do it again. 392 was a parts per million in the atmosphere 50 million years ago, minus what was in the atmosphere pre-industrial. That means nature removed 107 parts per million over a period of 50 million years. Carbon put back in the atmosphere by human activity is 130. But I just figured out there has to be at least twice as much already there. So we're going to do the same calculation now with 260 instead of 130. And you get down the bottom, you come out to 107 degrees. Nothing is alive on Earth. No plants, no animals, no nothing. By the time all of this carbon has spread throughout. The CO2 has risen up into the troposphere. When all of the CO2 molecules or the carbon molecules have absorbed all of the energy they can and they're radiating it back to Earth, we cook the planet. This is the end of episode 5. So you should now understand that there is already far more carbon in the atmosphere than what's needed to one day make the Earth unlivable for all human life. And on that cheery note, I'll leave you, but in episode 6, I will try and explain to you what we can do about it.